All right, in this video, I'm going to show you how one way of getting to do motions that are piecewise. So the motion has one characteristic for a certain amount of time, and then it changes its behavior in another. And I'll do a pretty simple one with the same sort of setup as before, define some parameter that's going to run the simulation forward in time. And I'm going to have two stages. Stage one, I'm going to be sort of constant position. So my function that describes the motion of the particle is for all times, it's just at the value of the initial position, and I've set that equal to 1. I've put some domain restrictions on there that I'll talk about later, but there's two things that my domain restriction does. It says it only allows this function to be valid for times that are less than the simulation time and less than some other time. And it plots the position of that. And then I'll sort of close this and talk about stage 2. Stage 2 is a slightly more complicated motion. It's constant velocity. It starts at the initial position and then carries with some velocity. And this is the delta t. This is the time that this thing starts was not after some delay of 3 seconds. And so I have to sort of modify this function, and students are going to need some help doing that. And then I've restricted this, since it's the second motion, it starts at 3 seconds. I only want this equation to be valid for simulation times, for times that are larger than 3 seconds, because the second motion doesn't start at this point, and that it only exists for times less than the simulation. And so what you can see is for stage 1, sort of goes along, and then it stops and changes to the stage 2 motion. If I hadn't sort of had this domain restriction here, if I take away the domain restriction that it's less than this, what's going to happen is that other motion will continue, and so it needs to be less than two things. It needs to be less than the time that that motion ends, and needs to be less than the simulation time. If you don't want to make it less than the simulation time, then what happens is that motion is just, that graph is there all the time. And so it doesn't sort of get created in real simulation time. And so same thing happens down here. I've restricted the domain so that that one doesn't start until the second motion is supposed to start and is still less than the and so that requires a little bit of work for your students, and it may not be something that you want to explore, having them learn how to use these domain restrictions, using new things like minimums, and also how to shift time delay the start of a motion with sort of a horizontal shift. But it does allow you to do some more complicated things, and so it can be useful depending on what you want your students to do.